We now come to the part number 2 of the machine voice. Okay, what is the name of this? It is a movable jaw. So it can be moved along the guideways of the body, and the workpiece can be fixed. So one in a body, there is a one fixed jaw is there. Okay, so this is called as a fixed jaw. And next is we are going for the movable jaw, which is going to fix to the body, and it can be slided over the body on the guideways to fix the particular workpiece. Okay, this is called as a movable jaw. So now, how to create this particular part by using these 2D views, that is orthographic views. And here this is a front view, and this is right side view, and this is the bottom side view. Okay, looking from the bottom, how it looks. This is what. Looking from the right, how it can be seen. What are the features we can see from the right. So this is a first angle of projection. Right side view is done on left side, and bottom view is done on the top of this. So this is a first angle of projection. So now, let me construct a profile similar to this one. Okay, T shape is there, no? T shape. Okay, similar to this, we need to construct a profile. Okay, this is a right side view. What is front view? Front view will be like this. Front view will be like this. This shape of this. Okay, so now let me create a shape like this. That is in T shape. What is the total width? 100 millimeters. And here this width is 40. Okay, and total height from here to here it is that is 45 plus 25 plus 3. 45 plus 25 means 70. 70 plus 3 means 73. From here to here, its total height is 73 millimeters. Okay, and width is 40 millimeters. Okay, and this width is 100 millimeters. And what about this width? This width is 25 plus 3. Okay, so this is if you project this, it will come here. So from here to here, what is the total height from the top? 25 plus 3. 25 plus 3, that is equal to 28 millimeters. So later we can create all these holes. Okay, there is a threaded hole and these holes and all. You just create this as it is like this. Now go to solid edge. Click on this. Click on the solid edge. Since it is a part, 3D part, click on solid part. Click on solid part. Only single click is enough. Now go to protrusion. Go to protrusion. Since it is not circular or symmetric, it is other than that, it is a rectangular in shape. See here, this shape is rectangular, and this side it has some width. SWIFT, it is similar to that. Okay, it is other than circular and symmetric object. Since because of that, we can go for the protrusion option. Okay, now select any view. Okay, any plane you can select. Let me select a front view. Now create a profile as it is like this in a T shape. As it is in a T shape. So now go to line option. Click on line option. Just observe here. As it is, see here, whenever this appears like this, you deactivate this one. So now in this fashion it will come once again up to here. It will come up to here once again. Up to the end of this. In a T shape, however we required, you construct this. While constructing itself, you can give the dimension, not a problem. Or else just create a rough sketch. Later we can give the dimension. I told you the distance from here to here, it is how much totally? What is the distance? 45, 25 plus 3. 25 plus 3 is 28 plus 45. How much? 73. Correct. Total it is from the year to year, it is 73. Therefore, from year to year, it is 73. In side view, you can, in front view, you can calculate. Side view, we don't have a dimension. Total height is 73. 73. Once again, okay, this width is from year to year. Okay, from year to year, it is 25 plus 3. How much? From year to year, 25 plus 3 is 28 millimeters. So now once again this is 28 millimeters. This is 28 millimeters. 28 millimeters. Okay, now we need to make symmetric about this plane. We need to make this symmetric with respect to this plane. How to make that? Click on symmetric. First click on the plane about which the profile is symmetric. This is a plane. So now click on the symmetric relationships. Now click on the vertical lines. Now it is symmetric. Once again click on these two lines. It will be symmetric. Okay. So now whatever the distance which you are giving, okay, to this, it will be equally divided. So now for example it is 40 here, width is 40. So now I will go to symmetric, smart dimension, click on this. It is how much? 40. So here it is going to take equally both the sides. Now you can drag this. See, both the sides it will come. If you hold and drag one line, it will come both the sides because we have given symmetric relationship. Okay, after this, I told you, and this width is how much? This width is total, it is 100 millimeters. 100 millimeters. See here? This width is totally 100 millimeters. This width is totally 100 millimeters. Anything else here? Any doubt here?
No, sir.
Okay, this side also it will come same 28 only. No need to give dimension. See, if you give one more dimension, okay, it will appear in blue color. See here? Blue color both. But here this is in black color. If you give one time, it will come in black time. What is that? In a black color. Same dimension, if you give once again, it will come in a blue color. That is completely arrested. What is the meaning of this? It is completely arrested if you give it. And one of the student actually personally sent a message, sir, whenever I change this particular dimension to 150, if it is 100, if I want to change this 150, I am unable to change it. He is asking. So what is the problem, sir? He is asking. Okay, for that reason, what the mistake or error you have done is, I will tell you, maybe settings problem. While creating smart dimension, if you lack this driving, then it will not change. So here, for example, I will give 150. Here, it will not change. And here also, if I lack this, it will not change. See here, 150. See, it won't change. That means, while constructing a profile, any profile, and while giving the dimension, if you lack this one, then it will not change. See, it will come in which color? Blue color. Are you able to see this? It is coming in blue color, not in black color. Black color is there means we can change. If it is coming in blue color, we cannot change it. It is fixed. See, for example, I want to make this 50, it will not change. See here? If I want to make this 50, it will not change. For the reason? Here it is locked completely. So we cannot change it. See here now, it has appeared in black. Click on this. So click on this driving, that is a lock symbol. Then it will appear in a black color. Then we can change it. Here. This is 30. Clear? Any doubts in this?
No,
Okay.
sir.
I think Vignesh has asked
Yes,
this
sir.
question. Vignesh has asked this question. Today is not in the class. Okay. That is what. Okay. While creating, be careful. If by mistake, if you lag this, you cannot change the dimension. For example, if I give here, say it will appear in blue color. I cannot change this. Whenever the dimensions are in black color, that can be edited, that can be changed to any length. But whenever this appears in a blue color like this, we cannot change it. For example, I want to make this 50, it will not change. Only this value is going to change, but distance remains same. What is the reason for that? Because we have locked this. Therefore, unlock this by clicking on this. See? This is happens because already we have given this. Simply remove it. Be careful. It should be open. It should be highlighted here. It should not be locked. Okay. So now this is what the profile which you need to create. Now go to return option. Go to return option. Click on symmetric extend. Second option. Okay. That means from the mid of the plane, it will extend in a symmetric way. That is, whatever that side we have, this side also will take same dimension. So that is, now what is the width here? You can see in the front view, total width is 50. Therefore, width I will give it as 50 millimeters per center. Finish it. Here, this shape we have created. Later we have to do the different operations. Okay. Now, in a side view, what in a front view, what we have to do is we need to remove this material, and we need to remove this material. We need to remove this material, and we need to remove this material. For that, what I am doing is click on cutout. To remove the material, click on cutout, select this face. Click on cutout and select this face. So now what I am doing is I will construct a profile which is exactly to cut the material at this position, and here also to cut the material exactly at this position I need to construct a profile. Profile means sketch. So now what is the total height from here to here? What is the height? What is the height? 25. And what about this one? This width?
55.
And this width is 5 millimeters.
5, sir.
5 millimeters. Now, what I did is go to cutout because we are just removing the material. Then select this face. So now, click on this rectangle. Click on this rectangle. Just try some rectangle. So now I told you this width is how much? This length is how much? 25. So now click on this collinear, and this should be collinear with respect to the surface. So now I told you the distance from here to here, it is how much? 5 millimeters. Any doubts in this sketch? 25. This width is 5 millimeters, and this is 25 from the top face. From the top face, it is 25. What about here? Okay, from here, what is the here width is how much? This width is how much? From any, okay, anyone tell me? What about this width? Out of 50, 50 minus 35 minus 5. How much? 50 minus 35 minus 5. How much is
10,
this?
sir.
10.
10.
Okay, now from here to
10,
here,
sir.
what is the height? Okay, what is the height from here to here? What is the height from here to here? Okay, now here it is given
10,
40.
sir.
Okay, 45 plus 10, it is 55. 45 plus 10 is 55. What is the total length from here to here? What is the total length from here to here?
28.
Hey, from bottom to the top face. 45.
Sir, 55, sir. 10 plus
40, sir.
45.
70.
No, from here to from top face to the bottom.
70,
Total
sir.
height.
70.
No, 45 plus 25, 70 plus 3. How much?
73, sir.
73. Okay. 73, out of 73, okay, 73 minus 45 minus 10, how much? To get this, 73 minus this much, 45 minus, minus 45 minus 10, that is minus 55. That is 73 minus 55. Are you getting what I am telling? So this total length is 73, out of which we have a distance of
80, sir.
55, we have a distance here from here to here. Therefore, remaining distance is whatever you are getting 73 minus 55. So now let me let me draw one rectangle from here. I told you this width is 10 millimeters, correct? This width is 10. Sorry, from here to here. From this end to this end, it is 10 millimeters. 10 millimeters. And once again, this distance is 73 minus 55. 73 minus 55, how much? 73 minus 55, how much? 18.
80, sir.
Total, it is 73. Total, it is 73. Any doubts in this? Any doubts?
No.
Here, this is right side and this is left side. This is left side and this is right side. The cutout dimension is 25 and here in this direction 5. 5 by 25. And here in this direction 10, that is 50 minus 40. If you do that, you will get 10 millimeters. And this is 73 minus 55. Okay, this width is, this height is how much? That is 73 minus
18, sir.
55, 18. Okay. Now go to return option. Okay, what is the extent we need to do here? Throughout the length of this. Simply you drag this and end it. Finish it. Are you able to see this now? This cutout. Can I say a cutout? Oh,
Yes, sir.
see how this is coming here. See here? Okay, now we have a radius here. What about the radius here? At this position, at this corner, what is the radius? 3, sorry, 10. What about here? It is 3. At this corner, it is a 3. And at this edge, okay, it is 10 millimeters radius. So now what I am doing is, now click on this round, that is fillet. Round means it is making round. Now click on this particular edge. Now what is the radius here for this? What is the radius? It is 10 millimeters. Enter 10 millimeters, press enter 2 times. Press enter 2 times. Okay, now similarly here also we have a one small radius, that is 3 millimeters. Okay, so now at this position, okay, at this position, at this along this corner, we have a 3 millimeters radius. Press 2 times, it will come. Okay, after this, after making the fillets, let me come for making this hole. Okay, what is this hole? Thread pi 20 into 2. So it is made throughout the length of this. See in this front view you can see, it is made throughout the length of this. In the hidden line we can see here, right? It is made throughout the length. What is the diameter? Pi 22. It is threaded. Square threaded is telling that it is threaded. Pi 20 into 2. Now we need to do the hole. Where it is made here? It is made at this position, at this space. Correct? It is made where? This is a T shape, right? It is made exactly parallel to that. So now go to, shall I go for the cutout or a hole here? It is a threaded. It is telling that it is threaded hole. Shall I go for the hole or a cutout? If it is threaded hole, then we need to go for the hole.
Sir, hole, sir.
Okay, then click on this space.
Hole, sir.
Go to hole option. I told you this is threaded hole. And diameter is how much? Diameter is 20 millimeters. It will take automatically M20, don't worry. and we don't have any V bottom here, and this is throughout the length of this, second throughout the next. Click on this, and there we can see hole with a thread. Okay, then place it exactly on the center. This is the center of this, the mid of this, right? You place it anywhere here. Then what is the position from the bottom? You check it. Okay, from the top it is given. From the top it is given. This is 15.5. Here 15.5 plus 27. 15.5 plus 27. 15.5 plus 27. How much totally? How much? 15.5 plus 27. 15.5 plus 27, and from here to here it is this width is 25. Half of that means how much? 12.5. 12.5 plus.
Sir,
Okay, do one thing. So before going to that, let me create that one. Okay. Okay, let me explain how to create first this one. Okay, otherwise ನಿಮಗೆ ಗೊತ್ತಾಗಲ್ಲ ಅದು ಡಿಸ್ಟೆನ್ಸ್ ಹೇಗೆ ತೊಗೊಳೋದು ಅಂತ ಗೊತ್ತಾಗೋದಿಲ್ಲ. Therefore, I will go for this one. So now here he has made two holes here. What are the two holes? 5 mm, and depth is how much? 13. And tap M6, depth is 10 millimeters. That is M6 threaded hole. Thread length is 10 millimeters. Hole depth is 13 millimeters. Hole depth is 13 and thread depth is 10 millimeters. It is once again 5. That is M5 ತಗೋಬಹುದು ನಾವು. M6 ತಗೊಂಡ್ರೆ ಬರೋದಿಲ್ಲ. M5 or M6 ತಗೋಬೇಕಾಗುತ್ತೆ. So now go to it is a threaded hole once again. Hole only. Click on that. Now where the holes are made? Exactly on this space. Exactly on this space. Now click on this. Go to hole option. Now it is a threaded hole. I told you here it is M6. Straight away here you select M6 here. Straight away you select M6. This 5 M5 and M6. It will come here 6 here. 6 millimeters will come. Don't worry. So now it is here we have, and this side we can see here. Yes, we have a V bottom here. Let it be V bottom. And what is thread depth? What is the thread depth here? Thread depth is 10 millimeters. What is the hole depth? Hole depth is 13 millimeters. Here, hole depth is 13 millimeters. Thread depth is 10 millimeters. And this is M6. So we have selected M6. Automatically diameter will come 6, not 5. If you select M6, it will come 6 mm only. Okay, we cannot change it. So now here the thread length is, there is a depth is 10 millimeters and hole depth is 13 millimeters. We have a V bottom, then place it on. There is a click on OK. Then somewhere, okay, don't click on this red color line here. Okay, somewhere here you place it. So here I don't have any disturbance here. So here it will come a tangential. Later we cannot change the position. Therefore, still move upward direction here. Still that disappears. Still that red color line as well as that tangential symbol should disappear. Okay, move it upward. Place it now. Okay, now I told you what the position of this from here to here, from the mid of this, it is 30 millimeters. Total here 60 is there. From the mid plane it is 30. Half of that. From the mid it is 30. Okay, from mid of this it is how much? 30. So now what about in this direction? What is the position of this? Okay, what is the position of this? So here he has given from this face bottom. How much is this? From the bottom, how much is this? From the bottom, how much is this? 15. From the bottom, from here, how much? 15 point. Okay, from this from this end or this end? From the bottom,
15.5.
right? From the bottom, it is 15.5. 15.5. 15.5. This side also we have same thing here, right? Right side also we have same thing. Therefore, go to mirror option here. Click on mirror. Select this with respect to mid of this plane. Then right click. Finish it. Okay, we have mirrored exactly with respect to mid of this plane. Once again, I will show you how to mirror this. Go to, let's click on mirror. Select the entity which you want to mirror. It is asking the plane with respect to which plane? With respect to mid plane. Click on this. It will come. Press enter. Or else right click. Right click on your mouse. Then go to return option. Return option. Which side we need? This side. Place it. Finish it. Are you able to see this green color marking that represents a thread? Once again, keep this in the right side view and keep it in visible and hidden edges. So here, are you able to see this hole? Okay, these are the holes which are made here. Are you able to see it? See here, holes we have done it. Okay, so now after the holes, now we can go for this. Now we have got the position here. So now we can go for this hole, diameter 20, and depth is throughout the length of this, throughout the length of 50. Throughout the length of 50, we need to make that hole. Now go to hole only. Now select this face, because this hole is made once again on this face only. Now click on the hole option. Now I told you it is threaded and diameter is 20. Select 20. Okay. So now it is threaded hole actually throughout the length to the whole extent only, because throughout the length to the whole extent. Thread is throughout the whole extent. Now we don't have V bottom here. Remove it. And here, throw next. Click on throw next. Throughout the next, it will go. So here, it will go throughout the next. Up to throughout the part, it will there. Next, click on OK. So now place it exactly in the middle of this plane. Place it. Now, what is the position now? Oh, see here, he has given the position from this center of the hole to this center. 27 plus 15.5. So now, smart dimension. Select this hole and this hole. How much totally? How much? 27 plus 55. 27 plus 15.5. 27 plus 15.5 is equal to 42.5. Total it is 42.5 millimeters. Now click on return. So now this is throughout the length of this. Just place it, it will come. Finish it. See here, it is a threaded hole of pi 20 millimeters. If you want, you can see here. Format view, you can textures, you can see the threaded hole here. Inside that, you can see the threads. Are you able to see that? Threads. Now, I don't want to show that.
Yes, sir.
Click on view. You uncheck this texture. You can OK. So now it will disappear. Only that green mark, that is color will be there. That represents a thread. Don't worry. Okay. Okay. After this, anything else? This hole we have made, and this hole we have made. And here we have some holes here. He has made some holes here. Okay, what are the positions and what is the type of hole here? We can where is given here? L code is in this front view also is not given. Okay, here hole information is not given. Okay, now from the bottom we need to go for the bottom. Looking from the bottom from here, how it can be seen here as given. So now what is the whole dimensions here? 2 holes pi 5 depth 13 and tab M6 depth 10. That is thread depth is 10, hole depth is 13. Hole depth 13, thread depth is 10. M6 means thread. Okay. So now it is a 24 millimeters. It is 12. This side 12. Both the side 12 and 12 millimeters. Now go to hole option. Because it is a threaded hole, select the bottom face. Select the bottom face, go to hole option. Okay, now I told you. Now what is the depth? There is a hole depth is 13 and thread depth is 10 and it is M6. Straight away select M6 and here you can select M6 straight away. Select M6, it will change here. It will change to 6 automatically whenever you select M6. Now, what is the whole extent here? Whole extent is 13. Whole extent is 13. What the thread extent? Whole extent is 13 and thread extent is 10 millimeters. Thread extent is 10 millimeters and it is M6. Okay. So here we don't have a V bottom, remove it. Whether we have a V bottom here? Yes, we have a V bottom here. Can you see here? We have a V bottom. If you want, we can give it. It is there, okay? It looks like V bottom only here. So give it. Okay, now click on OK. Then what is the position of this? Just exactly in the center of this, you place it. So now from the distance, from the center totally it is 24 is there. From the center of the plane is 12 millimeters, half of that. 12 millimeters, you give it, and this is 12 millimeters. This is 12 millimeters. Then click on mirror, select this, and click on this plane from where it has to be mirrored. Click on this, then right click. So now we have mirrored this entity with respect to this plane. If you want, you can measure this. What is the distance between from here to here? It is 12 only. It is 12 only. If you want, you can check this. Here, 12 only. Just we have mirrored it. That's all. It will come. Don't worry. Mirror it and finish the. Go to return. Which side we need here? Okay, this side. Finish it. So here you can see the holes here at the bottom. Front, you can front view. Click on visible edges. Are you able to see the holes here? Similar to this. Similar to this. Or see this. These are the holes which are made. Okay, now this completes, I think, movable jaw. All the features we have completed, which are given in the drawing. Fit it. Keep this isometric. Okay, now choose what is the material which is made of. What the material it is made of? Movable jaw. I think cast iron only. Movable jaw, cast iron. Cast iron. Material ಸ್ವಲ್ಪ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಯಾವುದೋ ಒಂದು ಹಾಕಿ ಅಷ್ಟೇ ತಲೆ ಕೆಡಿಸ್ಕೊಬಿಡಿ. Apply to model. Apply to model. Now file. File properties. What is this? Movable.
Movable jack.
Jack ಅಲ್ಲ jaw. 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 Control C. Click on OK. Then file. Okay. Save. Okay. Then Control V. Movable jaw. Save it. Close it. Let's go to next part. Part number 3. Okay. So this is a gripping jaw. What is the name of this? Jaw grip or a gripping jaw. See here? Jaw grip. Part number 3 is called as jaw grip. It is made of cast steel. A number of parts are 2. Jaw grips are 2 or in numbers. So it is made of cast steel. So now with respect to this part 3, what are the things which are given here? This is a front view and this is a side view. This is a front view and side view. So here what is the thickness of this? 8 millimeters, and this width is 28. Okay, this width is 28 and total length is 100. Okay, and here the all centers are 60 millimeters apart, and here we have a countersink hole here throughout the length. Countersink hole we have. So now I need to create a sketch like this. This is a rectangular shape. I need to extrude by an amount of 8 millimeters. Click on solid part, protrusion, then click on front plane, rectangle, simply draw one rectangle. So now I told you this 100 by 28, 100 by 28, and this is 100, and this is how much? 28. So now we need to make this symmetric with respect to these planes. How to make that? Click on this symmetric axis, then click on this horizontal plane, symmetric relationship, then click on these two parallel lines parallel to that line. Once again, click on symmetric axis, click on the vertical plane. So what are all the edges which are parallel to that vertical plane? Now click on the symmetric relationship, then parallel to that plane is this line and this line. Now it is exactly symmetric with respect to this center. That is symmetric with respect to horizontal plane as well as vertical plane. If you want, you can check this. It should be how much? 50 millimeters, right? 50 is there. And here it should be how much? 14 millimeters. It is there. Or else, sir, I don't know how to do this. Then do one thing. Go to smart dimension. Click on this. And here it is 50. So now from here to it is 14. You give the dimension. Or else use a symmetric relationship, or else give the dimension. Both are okay. Now go to return option. Symmetric. Click on symmetric extent. There is second option. So now what is the depth? What is the thickness? 8 millimeters. You give 8 millimeters, press enter. So this is a plate actually. So now on a plate he has made some holes here. Okay. Apart how much? 60 millimeters apart. And what type of hole here? Countersink hole. What type of hole? Countersink hole. Now it is a countersink hole. Okay. Go to hole option. Then click on this face or this face. Any side. Click on this face. Go to hole option. Okay, and it is a countersink hole. Select countersink hole. Now, countersink diameter is 12. You type countersink diameter, there is 12. And the hole diameter is how much? Hole diameter is 6.3. Hole diameter is 6.3. Countersink diameter is 12. And angle is how much? Angle is 90 degree. Angle is 90 degree. 90 degree, and the depth of the hole is throughout the next. Depth of the hole is throughout the next up to here. Up to here it will come. Okay. So these are the parameters. That is hole diameter is 6.3. Countersink diameter is 12. Okay. This diameter countersink diameter 12, and hole diameter 6.3. Okay. So now select here throughout the next. Hole depth is throughout the next, and the countersink angle is 90. Okay. Now where I need to place here? He has made 2 holes here. That is from the center it is how much? 30 millimeters. From the center of this it is 30 millimeters. Place it exactly in the center of this. Now go to smart dimension. Click on the plane and click on this one. This is how much? 60 by 2 means 30. Because Total length is how much? 60 is there. Half of that from the mid I am dividing. Okay, from the mid of this plane I am dividing. Okay, that is 60 by 2 means 30 millimeters. Okay, now go to mirror option here. Select this with respect to mid of this plane. Select this plane. With respect to this plane, we have mirrored it. Then right click. Go to return option. Which side I need to do? This side. Finish it. Are you able to see this hole? It is not a threaded hole. It is just it is a countersink hole here. Okay, we have made countersink hole. Here, here screw will come here. Screw will sit here. So this is the jaw. This part is completed. Okay, you neglect this small this grading scissor now. Okay, you neglect it, which we don't want here. This is called as knurling. We call it as a knurling. Technical words, we call it as knurling. For the gripping purpose, we have to do this. But here, it is not required. Leave it. Neglect it. So now click on isometric. Fit this. What the material it is made of? Cast steel. File properties, and this is jaw grip or gripping jaw. Control C, click OK, file, save this, OK, Control V, jaw grip, save this, close the part. You know, go to the next part number 4. What is part number 4? What is the part number 4 called? What is that?
Nut, sir.
Nut.
Bolt, sir.
Very sorry, Noda.
Bolt, sir.
It is a screw. It is a screw. Part number 4 is called as a screw. Okay. Part number 4 is called as a screw. It is M6. It is made of SE410. How many numbers are there? 6 numbers are there. So this is part number C is called as a screw. It's called as a screw M6. This is M6. How to create this screw? Since it is circular in nature, okay. Screw gottala nimge. This is circular and this is also circular. Pi 12 and this is pi 6. M6 means it is pi 6. That is diameter 6. M8 means diameter 8, like that. It is since it is M6, therefore diameter is 6, and this diameter is that is pi 12. Therefore, we can it is a symmetric and cylindrical object. It is symmetric and cylindrical object. That is circular object. Correct? So we can go for the revolve protrusion option for. Click on the solid edge. Since it is circular and symmetric about the axis, you can go for the revolve protrusion option. Select the front plane. Now I need to create only half of this portion. Only I need to create half of this portion. How to create that? Go to line. From the center, what is the total height? 16. Okay, you give 16 millimeters height. Then come in this direction. Okay, it is inclined here. Here in this. Okay, I am coming like this. Okay, like this. 16 millimeters, and I will come like this, and in this fashion, in the inclined way, it will come straight way, okay, and it will end here. Later you can give a dimension, don't worry, end it. So I told you this height is 16 overall height. Okay, now this diameter is how much? It is 12 is there. Half of that means how much? It is 6. What about here? It is totally 6 millimeters diameter. Half of that means how much? 3 millimeters. First give this 3 millimeters. This is 3. And this is 12 means it is 6 millimeters. And here it is total angle is 90 degrees there. Total angle is 90 degrees there. Half of that means how much? 45 degree. Click on angle between. So now click on this vertical edge and this inclined line. Don't click at the center of this line here. Okay. So here don't click at the center here. Whenever the center symbol appears, don't click here. Move this. Still move this. until that center of the line disappears. Then click on this. So much is this 45 degree. Okay, this is how much 45 degree. So here, I think to construct this screw, this is enough. And here he has given 3 millimeters. It will come automatically. No need to give here. If you want, you can check this. And here, from here to here, it will come how much? 3 millimeters. See here? How much? 3 millimeters. Whenever you give 6 millimeters here, and with the 45 degree angle, it will come how much? 3 millimeters automatically it will come. No need to give this. And total height is 16, and this diameter is 6 is there. Half of that I have given 6, and this diameter is 12 is there. There is a screw head 12 mm diameter. Half of that 6 millimeters I have given, and this angle is 45 degree. So this is completed. Now later we can create this. Don't worry. Now select axis of revolution. Select this plane. Select also this line. Not a problem. Click on this written. So how much degree? If you want a screw, how much degree? 360 degree. Click on this. Finish it. It's already you learnt in screw jack. There also we have constructed on CSK screw. Similar to that only. So now for the screwdriver gripping, we need to do the cutout here. What about this cutout? This is 1.6. This is 1.6 width. Width is how much? Width is how much? Width is 1.6. Okay, what about depth here? Depth of the cutout? 1.9. 1.6 and 1.5. That is we need to do the cutout here. To cut out, to do the cutout, that is to remove the material, we need to go for the cutout. Click on this cutout. You click on, I select either this plane or this plane. Any plane is okay. Any plane is okay. Either you can select this plane or this plane. Any plane you can select it. Okay, now rectangle. Rectangle. I told you what is the dimension of the rectangle. Depth is how much? Depth is 1.9. Separately create it 1.9. And width is how much? Width is 1.6. 1.6. Now go to move option. Select this. Select the center of this line. Select the center of this line. Now exactly keep it exactly on the center of this top face. See exactly on the center of this top face. Place it. So here we have created 1.9, 1.6. Now click on the return option. Which side we need to cut out here? Both the side or one side here? Both the side we need. Click on symmetric extent. Place it. Finish it off. Are you able to see this here? That cutout. What is the use of this cutout? What is the use of the cutout?
Screwdriver
rotate ಮಾಡಬೇಕಲ್ವಾ screw na, that is screwdriver gripping ಅದು. Okay. So now here he has made some threading, right? On the cylinder he has made threading. What is the here? M6. What is this? M6. How to do that thread here? See here we can see below the hole we have a thread option. We have thread option. Click on this. There is a straight thread. Click on that. Click on the cylinder where we need to do the thread. From where it has to be started. From where the thread has to be started here. Click on this end or this end. Anything okay. Click on this end. To the cylinder extent I need, correct. And this is M6 only, correct? Which one is this? What is this? M6. And that is M6. Now finish it. Are you able to see that? Threading. Format, view, textures. Click on this, we can see. You can see the threads and all we can see. Format, view, remove the texture, that is uncheck this, click on OK. The green color represents is the thread. So this completes your skew. Fit this, isometric. Now, tools, material table, FA 410, apply to model, file, and this is, before going to that, file properties, it is skew M6, copy this, Control C, press on OK. Next, file, save this, click on OK, Control V, see skew M6, that is, click on save. Now this skew is completed. Okay, close this file. Let's go to next part. Okay, so this is a skew rod. Okay, what is the name of this part? Skew rod. Part number? What is the part number 5? Skew rod. So here FE 410 and number is 1. FA 410 skew rod. And this is you can observe here. You can observe this is diameter, and this is also diameter, and this is also diameter, and here this is diameter, and this is diameter. It is circular object, cylindrical object, whether it is a cylindrical object or not. Circular and cylindrical. Yes, it is a cylindrical object and it has an axis of symmetry. Axis of symmetry means with respect to axis, whatever we have this side, we have the same thing this side also. And here also we have same thing. This side also we have same thing. And here we have whatever this side we have same thing. With respect to dimension, pHs, everything will be same with respect to axis. That's why it is called as it has an axis of symmetry. Okay, this part has an axis of symmetry and this is cylindrical in shape. Therefore, we can go for which option? Therefore, we can go for which option? It is cylindrical and symmetric. Which option? Revolve protrusion. Click on this revolve protrusion. Select the front plane. So now I need to create only half of this portion. Only this portion. Divide everything. Divide everything here. Only this half portion. This shape I am going to construct here. Shape of this. Only half portion here. So now what is the total length here? 250 plus 40. How much? 290. Total height is 290. Clear? So from this center it is how much? 290. You give 290 height. So the total length I told you 290. So now after this you come in this direction. Come down. Once again you should come inside. Once again straight. Once again you should go inside. Once again straight. Should go inside. Okay, how many steps are here? 1, 2, 3. 3 steps are here. Okay, 1, 2, 3 steps are there. So now what I am doing is go to line option from here. Okay, it will come like this. Okay, after this, there are 3 steps are there. 1, 2, 3. How many steps? 3 steps. Okay, this is one step, and this is one step, and this is one step. Now give the dimension from the bottom. That is from the minimum dimension. How much is this? M10 means half of that. How much? M10 means how much? M10.
M5.
That is 5. M10 means half of that. It is 5 millimeters. Next here it is 12 is there. How much is this? Half of that. 12 is there. It is half of that means 6. Okay, that is over. Next, what about here? It is 20 is there. 20 means half of that. How much?
10
20 means half of that means 10 millimeters. And once again here 32 is there. Half of that means how much? 16. So observe here, I have given the dimension from the bottom. For this, from the minimum dimension, I have given in the increasing way here. In the increasing way. Okay, after this is 16, 10. So we have divided everything, that's all. And this is 5 millimeters. So now give the depth here. What is the depth? 40. This is 40. Here is. Next, what about here? Total length. Okay, here at the bottom 22 is there. Give this. And this is 22. 22. And here after this, there is a second step is 18.
18.
And this is 18. Give this. Okay, after 18, how much is this? This is total length is 170 is a thread. Okay, 170 is a thread. Neglect the thread here. I am not considering thread now. Right now, 170 plus 40, how much? 170 plus 40. 170 plus 40. 2. 10. Automatically it will come. See here? How much? 210. No need to give the dimension. Automatically it will come. That is 210. How much? 210. So here 170 plus 40, remaining is 210. So here this is 210. No need to give the dimension, automatically it will come. 210. That is 290 minus 40 minus 22 minus 18 is 210. That is the meaning here. Okay, no need to give this. It is automatically it will come. So now click on axis of revolution. Axis of revolution is this is the one. This line also you can select, or else this axis also you can select. Let me select the line. Return option. Okay, 360 degree. Click on this revolve 360. Finish it. Okay. After this, here he has made some radius, that is fillet he has made, or diameter 3 millimeters. Now go to round option. So it is removing of sharp edges here. That is by using radius. What is the radius here? 3 millimeters, which is given. Press enter 2 times. Now that has been made. And once again, here thread he has made here. What is the thread here? What is the thread? What is the thread?
So 20.
M10. Thread is M10. Go to thread option. Straight thread. To select this end. At this end he has made M10 thread. From where it has to start? From this end. And here it is M10. You select this M10 and throughout the cylinder extent, finish it. Finish it. So thread we have made M10. Thread we have made M10. And here we don't have a thread. And here we have a thread here. And here we have a thread. What is the thread depth? 170. It is not throughout the length here. It is only 170 length. He has made threads here. What is the thread? It is a pi 20. Pi 20 means we have to take M20. M20. Pi 20 is equal to what? M20. M10 is equal to what? 10 diameter. So pi 20 means 20 diameter means we need to go for a what type of thread? M20. Now thread, click on this thread, straight thread. So now on this cylinder, here 40 millimeters we don't have a thread here. Remaining 170 is there now. Up to that 170 millimeters length we have a thread. That is the meaning here. So now from where it has to start here? From this end. From this end. Okay, now to the finite extent, it is 170 millimeters from here. So I have selected finite extent. It is 170 millimeters from this end. It is 170 millimeters from this end. So now it is M20. Select M20. Now finish it. Finish it. Sir, only 170 only we have done it, sir. but it is showing full, right, full color. Throughout the length it is showing color, sir. It is 210 millimeters color, it is showing 170 plus 40.
Yes, sir, 120.
Yes, but it is showing like this since it is V18 lower version. Okay, if you go for V19, it will show whatever you are doing. 170 means 170 only it will show. But just observe here. Okay, after saving this, I will show that. Okay, I will show after saving this. Don't worry. Okay, next, what else? He has done some hole here. Are you able to see this hole? What is the diameter of this hole? There we cannot see. In the top view, you can see here. In this view, this is the top view for this. And here, what is the diameter of this hole? What diameter is how much? Hole diameter. Hole diameter is 10 in the top view.
10, sir.
Yeah, here we don't have a top view. Okay, that's why I'm showing there. Here there should be a top view. There he has given this 10 millimeters diameter. Now we need to just do the hole, simple hole. It is a plain hole. Click on this cutout. So now you can select either this plane or this plane. Okay, either this plane or this plane. Any plane you can select it. Let me select this plane. Fit this. Zoom it. Go to circle. Exactly in the center of this. Exactly in the center of this. Draw a circle of diameter 10 millimeters. Of diameter 10 millimeters. So now he has given the, from the bottom here, from this head here, bottom to head, he has given the height 20 millimeters. Click on small dimension, click on this circle, is how much? 20 millimeters. It is 20 millimeters, okay. So now between this, it is exactly to the center, don't worry, we have already taken. That is, total 32 is there, half of that, how much? 16. Because already it is there. Click on return option. Okay, now symmetric extent, both sides it will come. So here, finish it. In the same fashion, other side also. Okay, now we have done the hole by selecting this plane. Now you select the other plane, perpendicular plane. You select this. Click on cutout. Select the perpendicular plane. See here. Well, already we have made in this direction here. In this direction. Now we are doing perpendicular to that. In the same fashion, circle, and here we can direct straight away. Okay, straight away to the center. Here, this is the center. And what is the diameter? 10 millimeters. If you want, you can see the, okay, it is from here to here it is 20. From this center to center it is 16. Okay. Now you can return. Both the side we need. Finish it. Both the side we need. See here. Zoom it. You can see here. See. The top view you can see. Zoom it. See here. Are you able to see this here? These holes. These holes which are made similar to here. See here. Not here. See here. This is what? Which you drawn here. Click on the visible edges with shaded. Keep this in isometric. Now the material. It is FA 410.
Okay.
Apply to model. File properties. What is the name of this? Screw rod. Control C. Okay. File. Save. Once again. Click on OK. Control V. Screw rod. Save this. Close this. Click on solid part. Go to next part here. Screw rod is over. It is part number 5 is over. Oh, hexagonal nut. Hexagonal nut. What is the size here? What is the size of this nut? What is
M10.
M10? Therefore, what are the sides of this hexagon? Sides of the hexagon is how much? What are the sides of the hexagon? Here, hexagon nut M10, hexagon nut M10 means it is a commercial part. The standards of the hexagon nut is as follows. Thickness of the nut is 0.90, that is 9 millimeters, and here no thickness is given here. Are you able to see here? No thickness is given, right? So for that reason, here it is given, but in some cases it will not give. 0.90, 0.90 means 9 millimeters, 0.9 into 10. How much? It is 9 millimeters. Where D is 10 millimeters, side length of the hexagon is equal to 10 millimeters only. That is, M10 means sides of the hexagon is how much? M10 only. If it is M12 means sides of the hexagon is 12 millimeters. If it is M15 means sides of the hexagon is equal to M15 only. Always keep it in mind. Okay. Here sides of the hexagon is not given. Here instead of that M10 is given. M10 means sides of the hexagon is M10 only. And thickness is given, not a problem here. Thickness of the nut is given, that is 5 millimeters. Now let me construct a nut like this. How to construct? I told you. We need to go for the protrusion first. Protrusion. Select the front plane. Now go to line option. So now we need to create hexagon of sides how much? 10 mm sides. Since it is M10, right? And 0 degree and 10. How much? For example, 60 degree. 10. Next 60 plus 60, right? 120. Next 10. First stamp. 180. 10. Next 240.
240.
Next close it. End point to where starting point to end point. You close it. Now go to move option. Select this. Before going to that, go to line option. You draw one line here. There is a diagonal. Go to move option. Select this midpoint and exactly place it on the mid of this there is origin of this plane. Exactly place this exactly at the center. Exactly at the center of this. Here while constructing the diagonal, be careful. Zoom it. Go to line option. From the end point to end point. Hexagon is not proper here. Check whether all the sides are same or not. Same only. Check the angle. 60. Go to line option, and here it is. M10 means 10 millimeters. And angle is 0 degree. 10 millimeters. And angle is 60. 10 millimeters. Angle is 120. 10 millimeters. Angle is 180. 10 millimeters. Angle is 240. Then end it. Zoom it. Zoom it. Draw the diagonal here. It should be a straight line. Should be a straight. So now go to move option. Select the center. Exactly place it on the exactly center of this. Now remove the diagonal. Remove this diagonal. Also we can create in the other way. Okay, also create the hexagon in another method. Directly straight away you can create. Here applications, macros, run macros, and here browse the folder here. Okay, we need to browse here. What is the path here? Local disk, program files, solid edge, custom, inside polygon. In that bin, okay, in that bin, in this path, okay, you can see here inside polygon. You can see inside polygon. Click on this, open it, select the flat length. Flat length is the sides of the hexagon 10 millimeters. How many number of sides we need? 6 millimeters. Then place it. See here, straight away we can create it. Are you able to see this? Straight away we can create this.
Yes.
10, 10, 10 like. Also manually by using angle and length method, we can construct the hexagon. Now go to return option, and I told you this thickness is how much? This thickness 5 millimeters. Click on symmetric extent, and this is 5 millimeters. Finish it. See here, this is the hexagonal nut, thickness 8 millimeters and shape is hexagon. So now after this he has made a hole here, that is a Hampton hole here. He has made Hampton hole, threaded hole. Now go to hole option here, click on this space, now hole option, and here it is thread, and here it is M10, and here to the hole extent, we don't want any V bottom here, M10, threaded, M10, click on this throw next, click on OK, then place it on the center, return, which side? Okay, this side, place it. This hole also we have done it. So now we need to do the chamfering here. That is chamfering of the nut. Both the side we need to do. Chamfering of the nut. Okay, this side, as well as about this side. Okay, we need to do the chamfering. I think this is one side is enough. What he has shown here. If you both the side, if you create means it is not a problem. It is not an issue. And how to create the chamfer here? I told you. Go to remove the material in 360 degree direction. You need to go for revolve cutout. Revolve cutout means to remove the material. Okay, whatever the degree we need 360 degree. Okay, here. Whatever the required profile, we can go for the revolve cutout. Click on this revolve cutout. So now select the plane. While selecting the plane, this is very important here. After selecting the revolve cutout, select the plane through which corner of the hexagon is passing. Select the plane through which corners of the hexagon is passing. Which one is the plane through which a corner is passing here? Which one is the plane? Shall I select this plane? Whether this plane is passing through the corner? Whether this plane is passing through the corner? No, right? Which plane is passing through the corner of the hexagon here? Which plane?
Horizontal plane.
Yes, this plane, right? This plane is passing through the corner of the hexagon, right?
Yes, sir.
Now select the plane through which corner of the hexagon is passing. Now select that plane. Now how many faces of the nut we can see here? 1, 2, 3. How many faces we can see here? 1, 2, 3. 3 faces we can see here. This is called a 3-face view. In such a way that we need to select here. Okay, if you select other plane, what happens here? Here, if I select this plane, just see how many faces we can see here. 1,
2, sir.
2 faces. Okay, we need 3-face view, not 2-face view. Like that, we need to select. So now select the plane passing through the corner. Now select the plane passing through the corner in order to get the three-phase view. Now select this, click on, okay, just zoom it. This is one face, right? And this is other face, and this is other face. If you want sketch view, just click on this, it will align. See, it will come. Zoom it now. Now we need to construct some profile that will remove the material in 360 degree at this edge as well as at this edge. You need to do the chamfering here. We have a sharp edges, right? These are sharp edges. These are sharp edges. Have you seen these nut and all? They used to make some chamfering to remove the sharp edges and all. That is called as chamfering to remove the sharp edges. Click on the sketch view. Zoom it. Now we need to construct one small profile here. You have to construct this. What is the method to do the chamfering here? That is very important here. From this end, you draw a line. So now chamfering angle is how much? 30 degree. With respect to center, you give 30 degree. This we have done already in 2D, right? Bolts and nuts, we have done it. So now, here we have a three face here. At this face, from the center, you draw one there is a mid of this face. From the mid of this face, you draw one line, so that it should touch this 30 degree line. Then here, go for the trim option, trim this extra line here. So meet. These two will meet exactly at this point. Now, go to arc by center point here. Arc by center point. Take this as center, and up to here as radius, you draw an arc. So now, trim option. Go to line option. From here, you draw a line up to this end and up to here. Okay, just some length. Go to trim option. I need only profile, only this much. Only this much I need. And this also I don't want. And this also I don't want. Only this much profile I need. Are you able to see this now?
Yes, sir.
Okay, this much profile only I need. Now go to line option. From here, to draw one line. You draw one line from this end, okay? From this end, you draw one line at an angle of 30 degree. An angle of how much? 30 degree. So what I am doing is, after trimming these unwanted lines, okay? After trimming these unwanted lines, zoom it. After constructing this, trim this. This also trim this also trim, and this also, right? Only this much portion only you keep. Now from this here, go to line option. From this end, intersection of this arc with this line, to draw one line at an angle of 30 degree. Just draw simply one line. Now angle between this and this is how much? 30 degree. Because chamfer angle is 30 degree. Now go to trim option, trim this also, okay, and go to select option, you remove this one. Okay, this is what I need. How much is the dimension for this triangle? You can see 0.1 and there is 0.79 and 1.38. Approximately you can give it 1 millimeters and 1.5 millimeters you can give it, not a problem here. 1 millimeters and 1.38 millimeters, directly you can give it. If you know it, directly you can give it. That means I'm going to line option. Straight away I will create, instead of doing all those things, straight away I will create this. So I told you how much is this? 0.79, right? How much is this? In the previous case, how much is what?
1.79.
0.79. And this is 1.39. It is 39. Okay, this is what we require. Directly we can create it if you know. Or else exactly you can create it. This is 1 millimeter, roughly you can create it. And this is 1.5 millimeters, roughly you can create it. Not a problem. Okay. Okay, now actual dimension what I got is 0.79 and 1.39. Now click on this return. Now we need to select the revolve axis. Click on this revolve axis. There is axis of revolution. Then click on this plane. Now go to return option. Okay, in which angle we need? What is the angle? 360 degree. Click on this revolve 360 degree, or simply you can enter 360 degree. Click on this revolve 360 degree, finish it off. So now chamfering we have done at the one end. Are you able to see this chamfering here? We have removed the sharp edges along the surface of the nut. Other side also we can do the same thing, right? Other side also, bottom side also we can do the same thing, right? Hello. Instead of doing,
Yes,
we can do the mirror here. Go for the mirror option. In this, mirror copy feature. Which one I need to mirror here? This is the cutout. Are you able to see this color here? This cutout has to be mirrored. Here select
Yes, sir, color.
select the smart dimension. Press enter or click on this. Press enter. Then it is asking the reference plane. From here it has to be mirrored here. From which plane it has to be mirrored?
Vertical plane.
Vertical plane, not vertical plane. Okay, with respect to this one. Okay, it will mirror with respect to this plane. You select this plane. See here? It will come. Finish it. So both the side we have mirrored it. Have you got this nut?
Yes, sir.
Okay, it is looks exactly like a nut only, right? Similarly, like a nut. Font, you can see
Yes,
the
sir.
threads inside. Format, view, select this texture. Okay. The threads you can see here inside. You can see the threads. Highlight these planes. See here. Are you able to see nut? Okay, any doubts in this creating nut? Talk to me. Any doubts? Other students?
No, sir.
No, sir.
If you want to show chamfering,
No,
I will
sir.
show once again. If you want to show chamfering, I will show once again. Okay. Once again, majority of the students are doing mistake here. I will show once again chamfering of the nut. I will show the chamfering of nut. Now go to revolve cutout because we need to remove the material in 360 degree direction. That is angle. Select revolve cutout and select the plane through which the corner is passing. That is three-phase view we need to select. For that we need to have a plane here. We need to have a plane here. I will unhide. That is, I will show the plane because I need here. Okay. So now go to revolve cutout. Now select the plane through which the corners are passing. Corners of the hexagon is passing. Now this is a plane through which the corners are passing. If you select this plane, you will get three-phase view. See here? You will get three-phase view. Three-phase view we need to select. In order to do like this, we need to select the plane which is passing through the corners of the hexagon. Now roughly we can create a triangle here. That is 1 millimeters and how much? 1.39, right? Or else follow the procedure if you have a time. From the center point to the center, draw the line. What should be the chamfering angle here? 30 degree.
30 degree.
30 degree. So now next, what is the next procedure? Go to line option. Just click on line option. From this face, mid of this face, draw one line such that it should intersect the 30 degree line. Now trim the excess line here. Now go to arc by center point option. Now from the center, there is intersection point. You take up to here as a radius, you draw an arc. Now zoom it, go to line option, from this end point, end of this, you draw a line. So now what I am doing is, I will trim these unwanted lines here, and this also I don't want. Okay, now we need 30-degree chamfering here on the sides of the nut. Therefore, click on this line option. From this intersection point, just draw a line. It should be how much angle with respect to horizontal? 30 degree. Okay. So now trim option. Trim these unwanted lines. Click on select. And see here. Okay. Or else roughly we can give 1 millimeters. Here it is not connected. If you want, you can connect this end with respect to this one. Okay, so now it is 1 millimeters, and this is, you can give it as 1.5. Roughly you can give it, not a problem. So now connect this end with respect to this one. Okay. So now this is not moving. Whenever you give 30 degree, it will not move. It will not move upward. Okay, it will not connect because trigonometry. According to trigonometry, this distance will not change because 30 degree we have maintained. So now extend this and end it. Roughly you can create it, not a problem. Extend this. You have extend option here. Extend this and trim this. It will come only 0.87 only. Now go to return option. Okay, we need to select axis of revolution. Click on this axis of revolution. Click on the axis. Return option. Now we need to do 360 degree revolution. Finish it. Other side also we need to do the same thing here. Therefore, we can directly go for the mirror feature. There is a mirror copy feature option. Now, which one is a feature which you want to mirror here? This cutout. About which plane? Select this point here. Then click on this. Now it is asking for the reference plane. Which plane? With respect to this plane.
Horizontal plane.
Horizontal plane, right? So now we have mirrored it. See here? Okay, like this we need to do the nut. Now tools. There is a material table. What is the material? FA 410 by 2 model. Keep this in isometric. File. That is file properties. This is a nut. And this is M10. Nut M10. Nut M10. Here always be careful. Size of the hexagon is not given. Size of the hexagon is equal to M10. M10 means 10 millimeters is the side. M12 means 12 millimeters is the side. M15 means 15 millimeters is the size of the hexagon. Be careful, size of the hexagon will not be given for the nuts and bolts. File, then save this. This is nut M10. Save this. Close it. Still how many parts? So last part is there. Okay. I will finish it off and I will end the class. If you want extend the class, I will extend half an hour. Okay. Last part is, what is the name of this part? What is the name of this part? We can see here. Last part. Okay, out of 9 parts, in the 9th part I am coming clamping plate. It is made of Fe410. It is made of Fe410. Okay, it is made of Fe410. one number. Now click on the solid part. And here, what are the dimensions which are given for that clamping plate? Okay, now for the clamping plate, width is 50, and this is 50-50 square, right? And this it is in square in nature,
Yes, sir.
and we have a thickness of 8 millimeters. Therefore, we can go for the protrusion option. Select any one of the plane, that is front plane. Now click on the rectangle option. This is 50. Press the tab 50, and angle is 0 degree. Place it here. Okay, now we need to do the alignment with respect to center. Now click on the symmetric axis. Click on this vertical plane. Then click on this symmetric relationship. Then parallel lines. Click on the parallel lines. It will align. Once again, change the axis now. Click on the symmetric axis. Click on the horizontal plane. Now, parallel lines are, these two are the parallel lines, which are symmetric. So now we can see here, this is 50, and this is 50. Okay, with respect to this 50, 50, 50, all this side it is 50, symmetric. Now go to return option, symmetric extent, and here, what is the thickness here? Thickness of this plate is how much? 8 millimeters. Press enter and finish it. Now plate, okay, of 8 millimeters thickness, it is a square plate. And here, he has done some holes here. What type of hole here he has made? What type of hole he has made? Counter sink hole. Countersink diameter is 12, and angle is 19, and the hole diameter is 6.3. Okay, and distance between these two holes is 24 millimeters. So now go to, since it is a threaded hole, go to hole option. Now you can select any face here, this face or this face. Any face you can select. Any face you can select. Any face you can select. Okay, now click on hole option, and I told you it is a countersink hole, and diameter of the hole is 6.3, and countersink is 12 millimeters, and angle is 90. Angle is 90. Whether we have a V bottom, we don't have V bottom here. Okay, you remove this, and this is throughout the length. So this is the shape what we require here. For that, it is given parameters is 12 millimeters, diameter 6, hole diameter 6.3, countersink the angle is 90 degree, and this is throughout the next. Click on OK. Then where I need to place here exactly? You can place it on this like this, or else here also you can place it. Let me select. Let me place here exactly in the center of this. Now, what is the distance from here to here, from the mid of this? From the mid of this is how much? From the mid of this, there is 24 means half of that. Half of that. Half of 24. Half of 24. How much? 12. Go to mirror option here. Go to there is a click on mirror option. Select the entity which you want to mirror. Okay, now with respect to mid plane, okay, with respect to this vertical plane, then right click. Yes, if you want, you can check this. Distance between this is how much? 24. Now return option. Which side we need? This side. Finish it off. Are you able to see this hole here? So here the screw will sit here. Okay, that's why he has made like this. Here screw will sit. Here. See? To place the screw, right? I have to assemble the two parts. He has done the like this, countersink holes. Now to accommodate the what? Screws. You can shaded way edges. So now isometric with this tools, material table, This is FE410. Now file properties. What is the name of this? What is the name of this part? Last part. That is clamping plate. Okay, that is clamping plate. Clamping plate. Select this, Control C. Press OK. File. Save this file. OK. Control V. That is clamping plate. Save it. Now this part is completed. Yav one part bittidivile. Whether we have done this part number 6. Washer. What about this washer? Part number 6. Okay, part number 6 is a very simple layer. Here.
No, sir.
Okay, so this is a part number 6. This is a washer, simple washer. Diameter is how much? 32. And thickness of this is 3. And the wall diameter is 10.5. Just go to protrusion, select front plane, go to circle. From the center, what is the diameter of that washer? 32. So draw a circle of 32 millimeters diameter. Okay, and go to return option. What is the thickness of the washer here? 3 millimeters. Click on symmetric extent. It is 3 millimeters diameter. Finish it. Now we need to make some small hole here. What is the hole diameter? 10.5. Now go to cutout option. Since it is a simple hole, click on this face, circle. From the center, you draw a circle of diameter 10.5. Go to return option. Okay, this side, you drag it. Finish it now. Okay, this is a washer which we required here. It is simple. Or else we can straight away we can create it here. See here, I will show you one more method. Go to protrusion, select the plane, click on circle. Outside circle is how much? 30. How much is this? 32. One more method. Inside circle is how much? 10.5. Inside circle is 10.5. Outside circle is 32. And wall inside circle, that is 10.5. Now click on return your overlap. Okay, 2 times write on this. Or remove one circle. Yeah. Return option. Now symmetric extent. What is the thickness of the washer? 3 millimeters. Press enter. So here at a time I have created hole as well as this washer. Here at a time. No need to do once again and again. So after creating this, once again go to cutout. Once again draw the circle of 10.5. No need to do. At a time we can complete. Any doubts in this? Tools, material table, FE410, apply to model, file properties. Okay, this is a washer. Select this, Control C, copy. Okay, file, save this. Okay, Control V, Control C, Control V. Now save this. Close it. So how many parts you have created? 1, 2, 3, 4, 5, 6, 7, 8. Right, one more. Which one is one more? Body, clamping plate.
9.
Mobilize is over, jack grip is over, screw is over, screw rod is over, washer is over, lock nut. One more is there here. Which one is that? Lock nut. Whether we have created this lock nut? No, not yet created, right?
Partner.
Okay, open the nut. Open the nut.
No,
I
sir.
will save this as lock nut. What is this? Lock nut. I will make save as lock nut because okay, lock nut dimension. You check it. This is also M10 and this is also M10. This is also M10 and this is also M10. Instead of 5 millimeter thickness, okay, there is a 8 millimeter thickness. That is the only difference. Instead of 5, how much? Thickness is how much here? Instead of 5, it is 8 millimeter thickness. That is the thing here. Okay, what
8,
we
sir.
have created is, I think here, it is 5 millimeters, right? Earlier we have created it for 5 millimeters thickness. Okay, then save this. Save this. Just I am checking the protrusion, right click, edit, definition. Click on this. I think this is 5 millimeters. Protrusion, edit, definition. So what we have created is for 8 millimeters. Okay, 8 millimeters is a lock nut. Okay, it is lock nut. See here, we can see here, 8 millimeters, sorry, 5 millimeters. What is the thickness we have given for this one while creating? Edit definition. I think 5 or 8. 8 could is 1. Okay, next we need to create 5
Yes,
millimeters
sir.
then. Okay, 8 is that is 8 millimeters means so this part number 7 is over. That is nut is over. Part number 7 is what? Is a nut. Part number 8 is lock nut. Part number 8 is lock nut. Now, only thing is we need to change the thickness. That's all. Nothing else here. See here? What is the difference between lock nut and nut here? Only thing is thickness. Here 8 millimeters is there. It is 5 here. It is M10, M10.
Lock nut is
Yes,
5
that's all. So what we can do here? Again,
millimeter thickness.
what we can change here? So here, go to cutout, sorry, go to protrusion, edit, edit definition. And here, select the second option, that is extension type. What should be the length we need to give here? 5 millimeters, right? 5 millimeters. What we need is 5 millimeters. Then finish it. Then finish it.
Yes, sir.
Here, created. Save this. So nut is over. That is part number 7. Part number 7, M8. Once again, I will give this. Anyhow, I have a doubt. Edit definition. Click on this extend step, and this is how much? 8 millimeters. Finish it. Initially, we created for 5 millimeters thickness. Okay, so now I am completing part number 7, that is nut. So this is 8 millimeters thickness. Now I need to do the chamfering here. I need to do the chamfering. Go to revolve cutout. Select the plane passing to the corners. 3-phase view we need to have here. Now go to line option. simply you can create a rough triangle, that is also okay. Or else, if you are following procedure, if you have a time, follow the procedure. Or else, simply you can create this triangle, that's all. But here, give the angle which is equal to 30 millimeters. And here roughly you can give this as this has 1.5 and this has 0.87. It will come automatically. Remove this. Select axis of revolution. Go to return option. 360-degree direction. Finish it. So now we need to mirror that one. Okay. Mirror copy feature. Smart dimension. Which one we need to mirror here? Cutout. Okay. Cutout. We need to mirror here. With respect to which plane? With respect to this plane. Now click on this. Select the plane from about which it has to be mirrored. Then finish it. Zoom it. Here, both the side we have done it. Yeah. So this is M10 nut, part number 7. This is part number 7. And here part number 8 is lock nut. Part number 8 is lock nut. It has a 5 millimeter thickness. See now ಒಂದು ಮಾಡಿಕೊಂಡು ನೀವು ಇನ್ನೊಂದನ್ನ ಕಾಪಿ ಪೇಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ ಇದು ಮಾಡ್ಕೊಳ್ಳಿ, ನಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾದ್ಮೇಲೆ ನಮ್ಗೆ ಈಸಿ ಮಾಡೋದು ನೋಡಿ ತೋರಿಸಿ ನಾನು. ಇಫ್ ಯು ಡೂ ದಿಸ್ ನಟ್ ಫಾರ್ 8 millimeter thickness, it is very easy to change here. ನೋಡಿ thickness change ಮಾಡೋದು very easy. Now I have for 8 millimeter thickness. Okay. So now I need to do here for 5 millimeters. How to change this? I have 8 millimeters thickness here. That is M7 I have here. Sorry, part number 7 I have here. Then how to convert this part number 7 to part number 8 by copying that itself. So what is that is to save the time and all. Okay. Save time save ಮಾಡಬಹುದು, right? Just copy, make it copy as after completing part number 7. Okay, now change this thickness as 5 millimeters. How to change that? Go to protrusion, edit, definition, and here second one, that is extension step, and give 5 millimeters thickness. Initially it was for 8 millimeters. Just change it to 5 millimeters thickness. Finish it. So it will come. See here? Are you able to see here? Just this 8 millimeters we have reduced to 5 millimeters. Then all the feature, the chamfer and all will come. All the feature, chamfering and all will come. Like that we can do. Simply we can create this one, the part number 7, and save that as part number 8, that is lock nut, and later edit the thickness as, that is 8, instead of 8 millimeters, change it to 5 millimeters. It will come. That is once again, you can save the time here. Okay, now all the parts we have completed. Next we can go for the assembly of this part. So like this we need to do all the parts.